Page 117, number 15. We are to find f of g of x and g of f of x. We're supposed to state the domain of each. So first, finding f of g of x means we take our g function and we are going to substitute it wherever there's an x in the f function. So f of g of x is going to equal 3 times x minus 1 plus 2. So simplifying, we get 3x minus 3 plus 2. So f of g of x is going to equal 3x minus 1. Now, the domain of f of g of x is going to be whatever the range is of g, plus if there's any excluded values from the final form of our function, which there are not because it's a line. 3x minus 1 defines a line. Now, if we look at g of x, what we can see is it is also a line, which is defined both for the domain and range as all real numbers. So the domain of f of g of x is going to be the set of real numbers. So now, to do g of f of x, we are going to do the opposite. We are going to take our f function and replace the x's in the g function with the f function. So that is going to give us 3x plus 2 minus 1. Simplifying, we get 3x plus 1. And that is all the simplifying we have to do. So g of f of x is 3x plus 1. And we're going to define our domain in the same way for g of f of x. And what we're going to see is that, again, we have a line being put into another line. So we have a range of our original line, f, being all real numbers. So that becomes the domain of our g. And it, again, has no restrictions because the final equation is a line. This is a line. So our domain is going to be as well all real numbers.